Sign up for CNN's Wonder Theory Science newsletter. Explore the universe with news on fascinating discoveries, scientific advancements and more. CNN. Picture a calm spring day 66 million years ago in what's now North Dakota. Perhaps a triceratops was lying in the sun, while in the river freshwater paddlefish, mouths gaping, were foraging plankton. Seconds later, a 10-meter-high, 33-foot-high, wall of water rushes in from the east and then spheres of glass start to rain down from the sky, some of them still on fire as they hit the river. These could have been the very last moments of the dinosaur era, which came to a cataclysmic end when a city-size asteroid struck the shallow ocean off Mexico's Yucatan Peninsula, killing off 3/4 of all species on Earth. According to a new study of fossilized fish that were found at North Dakota's Tanis fossil site and perished as a result of the devastating impact, the asteroid hit in springtime. The timing of the collision, at least for the Northern Hemisphere, came at a particularly sensitive stage in the biological life cycles of many plants It likely made what was already a disastrous event more catastrophic, said Melanie During, a doctoral student at Uppsala University in Sweden, the main author of a new study published in the journal Nature on Wednesday. Melanie During excavating a paddlefish in the Tanis deposit, North Dakota. I think spring puts a large group of the late Cretaceous biota, animal and plant life, in a very vulnerable spot because they were out and about looking for food, tending to offspring and trying to build up resources after the harsh winter, she said at a news briefing. By contrast, the researchers said that ecosystems in the southern hemisphere, where it was fall when the asteroid collided with Earth, appear to have bounced back nearly twice as fast as those in the northern hemisphere. Meet the man who can explain the first 3 billion years of life on our planet. Car crash frozen in place. How did the researchers manage to pinpoint the season in which the asteroid struck? Even though they were 3,000 kilometers, 1,864 miles, away from the impact crater, the bones of paddlefish and sturgeons preserved in rock at the Tanis site in the Hell Creek Formation provide a unique record of what was perhaps the most significant event in the history of life on our planet. The fish, which were up to a meter, 3 feet, long, died in a dramatic fashion immediately after the asteroid strike, buried alive by sediment displaced as a massive body of water unleashed by the asteroid strike moved upstream. Think of the ripples of water from a stone thrown into a pond, but on a much larger. Unlike tsunamis, which can take hours to reach land after an earthquake at sea, these moving water bodies, known as a sichi, surged out instantaneously after the massive asteroid crashed into the sea. A paddlefish from the Tanis fossil site. The researchers are certain that the fish died within an hour of the asteroid strike, and not as a result of the massive wildfires or the nuclear winter that came in the days and months that followed. That's because impact spherules, small bits of molten rock thrown up from the crater into space where they crystallized into a glass-like material, were found lodged in the fish's gills. These impact spherules, they got ejected into space, and some of them may have even circled the moon and then they rained back down on Earth. During this deposit literally looks like a car crash frozen in place. It looks like the most violent thing I have ever seen, preserved in pristine condition, she sighed off the fossil site. What's more, the fish were found just beneath a layer of rock known as the iridium anomaly, which is rich in a dense element common in asteroids and rare on Earth. It was the feature that first revealed the asteroid strike to geologists more than 3 decades ago. Geologic snapshot. A bit like tree rings, the fossilized fish skeletons preserve a diary of the animal's growth, from their development as embryos until their untimely demise. Analysis of thin slices of the bone, as well as the distribution, shape and size of the bone cells, which also fluctuate with the seasons, suggested Thathy died in spring. The team of researchers also looked at the chemical signatures of different carbon isotopes in one of the unfortunate paddlefish, with the ratio between different isotope variants revealing how the availability of its favorite food, plankton, had affected its skeleton. The isotope records suggested that the fish's annual growth, which would coincide with the peak availability of its prey in summer, hadn't yet been reached. The cut sections of fossilized fishbone prepared for analysis at the Vrije Universiteit in Brussels. Another, broader study of the same site published last year also pointed to a similar springtime frame, while a much older 1991 study of fossil leaves had suggested it happened in June. During said she thought the asteroid strike likely happened in April, but further research is needed for a definitive answer. Alfio Alessandro Chiarenza, a postdoctoral research fellow and paleontologist at Universidade de Vigo in Spain, who wasn't involved in the study, said, "This kind of research was very valuable for paleontologists. The Tanis site can offer some more important glimpses to understand this mass extinction, since we paleontologists have to deal with very coarse time resolution. Having the chance to analyze a geologic snapshot of a geologic event can further improve our understanding of this pivotal event in the history of our